going to learn the subject data structures. What is data structure, right? It is a set of mechanisms that are required to organize the logical and mathematical data over the system. Okay, data structures are classified into two types, linear and non-linear. Linear data structures such as stacks, queues, linked lists. Non-linear data structures such as trees and graphs. Okay, so these data structures, as I told you, that they are used to organize the data over the system, right? Why we need the data to be organized in a more systematic way, to make the retrieval more easier, right? So here again, after you organize the data, in a more systematic way, you need to put them in sorted order, so that it will be easy for you when you are retrieving the data, because you have different type of data being stored on the machine: integer, character, float, long, double, some implies information, student information, any company's information. So they all are belonging to different kind, and when you are retrieving them, if you could have sorted them after being organized as well in an order, it will be more easy for us to retrieve. So here, of course, we have some sorting techniques, starting from selection sort, bubble sort, we call it as exchange sort as well, quick sort, merge sort, heap sort, tree sort, and so on, radix sort, shell sort, etc., etc. These are some of the sorting techniques which we are going to study as part of our syllabus. Okay, so after we sort them in an ascending or descending order, then to retrieve the data as well, again we have some searching techniques. Okay, and here again I am classifying the searching techniques into two kinds, like internal and external. I am calling it as internal searching when I am searching the data from my internal memory, such as RAM, system memory. External searching I am calling when I am searching it from the external memory, such as hard disk or backup. We have some sort of searching techniques under internal searching, such as linear search, binary search. External searching techniques we have like hashing and B-trees. Okay. So what we are going to study, of course, in entire data structure is what this is what we are going to learn in data structures. Fine. So coming to now the linear data structures. Of course, we study all of these topics quite in detail when we are moving our syllabus, probably over the next classes. Now we'll have a brief look at this all different techniques. Moving on to linear data structures. Stack. What is stack? Stack is one of the linear data structure which is based on last in first out concept. What do you mean by last in first out here? When you are inserting the elements, you are inserting from lastly and retrieving. When you are retrieving the elements, you are retrieving from the front. Fine. So how do you implement here last in first out? Right. We are implementing here last in first out by performing both the insertion and deletion from the same end, that is top end. Okay. So here last in first out in the sense that the element which is inserted over the stack data structure lastly will come out firstly. Okay. So here if I take one horizontal stack and one variable top, let us say initially it is equal to -1, and index of this particular array, let us say 0, 1, 2, 3, 4, where the array size we have fixed it as 5, let us say. Okay. So when you are inserting an element, we call it as push function. So how do you perform the push function? You are going to insert an element over the stack by incrementing top first and then inserting the element over the stack where top is pointing. Okay. Similarly, you do operation for the rest of the subsequent elements as well. Another function which you perform in stack is pop, P-O-P, pop. So here this function is being used to perform deletions. So how do we perform deletion? We delete the element being pointed by top and then decrement top. Okay. So here in order to implement push and pop operations, what we need is certain data structures again, like arrays or linked lists. Okay. And coming to the applications of stacks, we have applications like to convert the expressions from infix to postfix, infix to prefix, postfix or prefix evaluation. Recursion is one of the important application, and by performing tree traversals, graph traversals, you need of course stack, and many of the gaming applications to implement you need stack. Okay, so what do you mean by infix expression? Generally we write the expressions how we write in mathematics. Okay, A plus B into C. So if you have a binary operator, left operand, then operator followed by the right operand. But in computer, it does not take if we give infix expression, because when we are giving expressions, we are giving as part of our programming. So these are all considered to be tokens in the programming language, which are going to be stored on the symbol table. So it is helpful for the compiler to retrieve and identify them as symbols, okay, from symbol tables, to distinguish and then identify them as operator or operand if you could have represented either in the prefix form or the postfix form. So what do you mean by postfix form? In postfix form, we are writing the operands, then followed by the operator. Okay, left operand, right operand, then followed by the operator. Okay, so let us say, for example, if you are given this particular expression, how do you convert it into postfix form? Again, when you are converting, you need to follow order of precedence here, right? What do you mean by order of precedence? It's nothing but the precedence given, the priority given to operators when you have multiple operators in an expression. Okay, so in general, if more priority will be given for the exponent, then the operations which are enclosed in parentheses, then into, divide, comma, mod with equal importance.